Go ahead.
All right, double click on sheet cam. File. Import drawing. We're going to the removable disk, the thumb drive that Nate gave us. Double click. Okay. Edit contours. Right click on the border. Move to a layer. New layer. I'm gonna name it the border. Now I've got the holes are on this ASI cut line is one layer, and the border is a layer I just created. Go to our magic wand, create a jet cutting tool. We want to do inside cutouts first. So we're going to do our inside offset because we're cutting the holes. Select the appropriate layer and select the appropriate tool, which this calls out for 1/8 inch material. We're going to use 45 amp consumables. Once that's selected, it tells us our voltage, which needs us to match our THC, the black box. It looks like an old VCR, VHS rewinder.
Please be kind and rewind.
Yep. It automatically sets our pierce height, our pierce delay, our feed rate. So the only other thing that we're concerned about is our lead-ins and our lead-outs. We're going to do an arc lead-in and an arc lead-out. And I always like to start with the thickness of the material, depending on the size of the hole. I click OK. Now it has generated a tool path. There's our lead in, goes counterclockwise on holes, our lead out. And it'll do that for all the holes in the drawing. Now we need to create a second layer, or I'm not a second layer, I'm sorry, a second jet cutting operation. In this situation, we're going to go with an outside offset because we're cutting the border, and we have to take the kerf into account and have the kerf of the plasma on the correct side of the cutout. Select our layer, which is border. The tool is still the same. We can leave our lead-ins and lead-outs the same. So if you look at the hole, that layer, you can see the lead-in and lead-out is on the inside. On our border, the lead in and lead out is on the outside. Again, taking into account the kerf width of the plasma stream. From here, File, Save Part As. We'll go to Desktop, we're going to go to our Training Day folder and save it there.
Can you copy that so it cuts two also?
That's what we'll do next.
Okay.
So now we've cammed this. We've created a part. We can now go to the nesting. Again, to the right side of my hand, those are going to be the tools that you're going to use on a regular basis. Typically, you're going to use edit contours, and that's going to be the first thing you're going to do. We can edit start points. This is the start point. So if I go to that tool, I can move that start point. On circles, it doesn't really matter because it's a circle. Then we can go to nesting. If we want two of these, we can go either duplicate or multiple duplicate, or if we want proper spacing in between and not just guessing by eye, we can go to array parts and we can do one column, 2 rows with a 1/4 inch spacing in the X, 1/4 inch spacing in the Y. Okay, so now I have 2 parts. I can file, since I've got 2 parts, this is actually a job. Save job as, and I'm gonna call it the name that Nate created, and then I'm gonna call it my nest. And then I'm gonna run the post processor. So it creates the G code with all the work we just went through. No errors because there's no red text at the bottom. And I'm good to go. So now I can go into, oops, it's already open. I can go into my trooper. I'm going to reset it, THC on, and reference all home. Those are the three things we have to do every single time we open up mock. So I'm going to drive this back because I can't remember if we homed it or not, but just to be sure. I'm going to reference all home. It's going to run through its sequence so it knows where it is on the table. I'm going to hit the upper limit switch for the Z. There's the X. Now it's going to drive the Y. I'm going to drive my torch about halfway down. Turn my laser pointer on. I'm going to drive my torch down to about an inch or so off the plate, zero out my coordinates, load my G code, check part fit. I've got plenty of plate. Cycle start.